All right, continuing on with the hyperbolas and ellipses. So we went with hyperbolas with their center point at the origin. Did that one. We also did it when it goes the other direction. Okay, so this is when it goes this way. This is when it goes this way. Okay, so now we're going to look at these ellipses and hyperbolas when they are not centered at the origin. So this may take 2 videos to get through. We shall see. So let's get rid of all of these. Remember those formulas. If you have them in your notes, kind of look at them because there's going to be a little bit of a difference in what the formula looks like. Let's look at ellipses first. This is the equation of an ellipse with a center not at the origin. So let me give you, first of all, at the origin. Okay, so there's with the center at the origin. Here is one, let's say the center is at 4, 1. And this is what the equation would look like. Okay? So for these ellipses, and if I accidentally say hyperbola, just ignore me. So for these ellipses, the center is going to be the opposite of this, okay? So if you're given the center, you write the equation as its opposite, x minus 4, x minus 1. If this was a negative 4, it would be x plus 4, y minus 1. So that is just something to keep in mind as you're doing these. And let me and it's just because we're distributing that negative, that's why it becomes that way. I'm not going to go into all the detail about this, but that gives me the center, 4, 1. So it's not really too terribly difficult to find the center. It's just whatever that is. In fact, the equation for this, let me do it in red here. Let's erase this here, and let me give you the equation for the hyperbola when the center is somewhere else. It's going to be x minus h squared over a squared plus y minus k quantity squared over b squared equals 1. And the h and the k are the center of the ellipse. They're also the center of a circle. So whenever you see hk, that's the center. So hk was 4 and 1. So we put a 4 here and a 1 here. Okay? So this is a minus only because the formula had the minus signs there. So you look and see what those numbers are. That's the center. What these numbers are is how far on the x-axis we are from the center. In this case, a squared, what number times itself? How can I write 9 as something squared? I can write it this way. I can write 4 as 2 squared. So the distance on the x-axis from the center point is going to be 3, both directions, plus or minus, and plus or minus on the y. So let's go ahead and do that. Plus or minus 3, and plus or minus minus 3, and then up 2, down 2, and we can draw our ellipse then based on that information. Okay, so not too terribly difficult. The only time that it starts getting a little bit rough is in this next example where they give you this kind of a psychotic equation here that they want you to solve. So here we go. I'm going to leave the formula up here, and I'm going to write example 3 up here. X squared plus 9y squared that does not look like like a 7. Writing 7s on an iPad are really kind of difficult. All right, so this is just like what we did with circles. We put all of our common letters together, so I'm going to move my X's together, and then I'm going to move my Y's together, and then I'm going to put my 76 over on the other side, subtract it from both sides. Okay, so now I'm going to complete the square. So I'm going to write this with a space between my X's. And at the end of my Y. So parentheses, parentheses. Okay, half of 4 squared. Okay, so I added 4 there. I've got to add 4 here. Okay. Half of my 54 squared. That does not seem very pleasant, does it? So what I'm going to do, I'm going to do something a little bit kind of weird here. So rather than do that, I'm going to see here, oh, wait a minute. I have a 9 in front of here, and I can't have a 9. I can't have anything in front of here. And I have a 54. I can factor something out of here. So I'm going to rewrite this. I mean, my X was okay. I didn't have a number in front of there. But I have a 9 that I can factor out. So I'm going to take 9. And that leaves me with y squared minus 6y. Okay, so I just factored the 9 out to make that easier. So I still have my negative 76 plus 4, which the 4 again came from over here. Whatever you do to the left side, you have to do the right side. All right, so half of 3 squared. Half of 6 is 3, squared it is 9. So I've got that. All right, so just like I did with the x's, I added a 4 here, so I added it here. I added a 9, it looks like, but I really didn't add a 9. I added 9 times 9, because remember, I factored the 9 out. So if I were to put the 9 back in to get my original problem, I'd have to multiply this times this, this, and this. So I really added 81 to that side. Okay, so don't forget to do that. All right, so that gives me x plus square root of 4 is 2. And I will leave that 9 there. And I've got a y squared minus square root of this 9 is 3 equals negative 76 plus 81 plus 4 is going to give me 9. Okay. Now, the next part is, remember, this number here, come on, this 9 cannot be a 9 in our equation. Up here it has to be a 1. So remember, I have to multiply this by a 9, this by a 9, and this by a 9. And what happens here? 9 over 9 gives me 1. And I have a 9 over 9 there, so that goes away. So what I've got here is my final product is I like to put that over 1, even though my 9's canceled. I need to put that 1 on there so I know how to graph it. Because this, so my center point is going to be my center is going to be negative 2, 3, right? The opposite of this, negative 2, 3. And my ends of my ellipse are going to be on the x-axis, plus or minus 3, because the square root of 9 is plus or minus 3. Square root of 1 is plus or minus 1. So that gives me negative 2. I'm going to erase a bunch of this junk here out of my graph way. And so I've got negative 2, 3 for my center point. Okay. And my x distance is going to be plus or minus 3. So 1, 2, 3. 1, 2, 3. And my up and down is going to be plus or minus 1. So it's going to be a real squished ellipse. But that's what I end up getting. So yeah, there's a lot of work to doing this. It ends up not being real easy. And sorry to say, dealing with hyperbolas, which we're going to do now, is not going to get, it's not going to be any harder, but it's not going to be any easier. All right, so let's get started with the hyperbolas. And first of all, I want to give you the formula for the hyperbola. So it's going to be x minus h, quantity squared, over a squared. And it's going to be minus, again, the only difference between the hyperbola and the ellipse is the hyperbola has a minus sign here, and the hyperbola, or the ellipse, has a plus sign. But other than that, it's the exact same, which means you solve them the exact same way. All right, so in this case, the x is first, so that means it's going to give you a shape this way. If this were written with the y first, it would give you a shape that way. Okay, so just keep in mind when you're looking at these, if the x's are first, it's going to be one way. The y's are first, it's another way. All right, so first of all, whatever equation they give us, and in this case, they give us 4x squared minus y squared plus 4y minus 20 equals 0. All right, so first thing we're going to have to do is put everything in the right order. So the thing is, we only have an 4x squared. We don't have an x, so that's going to stay the same. And y squared, we have our plus 4y. Those are next to each other. We're going to move our 20 over. Okay? So one thing that's necessary to explain, because, I mean, see, we have a y squared and a y here. We have just an x squared. We don't have an x. So because we don't have an x, we don't have to complete the square over there. So that makes life a bit easier. So all we have to do is complete the square with the y's here. All right, so we're going to leave the 4x squared alone. And one of the things that ends up being a pain in the neck is this doggone negative right here. Because now we have a negative y squared, and we don't want a negative y squared. We just want a y squared. So I'm going to put this in parentheses. And I have to change the y here to a negative. Okay, because what I did is I actually factored out a negative 1. I don't have to write that 1 because it doesn't change the value of anything. But that's what I did. I pulled a negative off of this y squared, but if I pull it off of this, I have to also pull it off of here because, see, I have in parentheses. So I've got a minus, a positive y squared minus 4y. So if I distribute this negative back, I get my negative, and I get my negative 4 here, or a positive 4 here. Negative times negative gives me a positive. So I did that, put it in parentheses, so now that I can complete the square. So okay. So what do? Half of this, square it to put that term there in there. Let's put that in there in black. So I added 4 there, have to add 4 there. Except I didn't add 4 there. I subtracted 4. A negative 1 times 4 is negative 4. So this needs to be a negative. So make sure you don't make the mistake and put that in there as a positive 4. So that gives me 4x squared minus y minus 2 quantity squared equals 16. So remember, square root of that, sine, square root of that, and it equals that. Okay, so that looks real nice and pretty at this point. Okay. Problem is, there's a 16 here. It has to be a 1. So I'm going to divide each term. Okay, give me that. So now I have this reduces to x squared over 4. This can't reduce. And that reduces to 16 over 16, reduces to 1. Okay, so that puts us in a place where we can actually graph this guy, because I know I'm going to make my box, and I also need to know where the center of that box is. Well, the center of that box is whatever this minus number is, which there isn't one there. So because there isn't a number there, it ends up being 0. And this number is a 2. So that's the center of my hyperbola. I'm going to import another graph here, so I'm not going up and down with it, trying to make it work. Okay, so my center is at 0, 2. And 2 left to right, square root of 4 is 2. Because it's underneath the x, it's going to be left to right 2. So 2 this way, 2 this way. And then I look at this here, and this is a 16, and it's on the y, so that means it goes up or down 4, square root of 16. Okay, then I can draw my cool little asymptote here. I'm sorry, it's not very pretty. And because the x is first, it's going to look, let me get my black ink. Oh, come on, my black ink here. There we go. So that's the answer. So that is 10.2, the last lesson of the entire book.